Let us talk about this question. For the matrices A and B, verify that AB whole transpose is equal to B transpose times A transpose. Okay, this is a property of transpose, and we are supposed to verify this property for these two given matrices. Okay, this is the first part. Let's try to solve this and prove this. Verify this basically. How do we go about doing that? So in the LHS, as you may observe, you have the product AB. First, we have to find the product AB, and then we have to take the transpose of that. Okay. For the RHS, we have to take the transpose first and then find the product. Okay. The product B transpose times A transpose. Okay. Let's try to do it. So given matrices A and B, can I easily find the product first? Okay. So given A equals this matrix 1 minus 4 3 and B equals minus 1 2 1. Given these two matrices, implies product AB will be equal to what? Product AB is 1 minus 4 3 times minus 1 2 1. This is the product. What will this product be equal to? Okay. For multiplying this is a 3 by 1 matrix. This is a 1 by 3 matrix. Okay. Is this matrix product? Does this matrix product exist? Yes. Are these matrices, the product can be found for these? Yes. These two numbers are same. That is, the number of columns in this will be equal to the number of rows in this. Yes. And therefore, the matrix product exists. And what will be the final order of the product? The final order would be 3 by 3. So we will get a 3 by 3 matrix. Okay. A big matrix, 3 by 3 matrix. Now, what is that matrix equal to? Let's take a look at this. The first row gets multiplied with the first column to give us this element. So 1 gets multiplied with minus 1. There's nothing to add after that, right? This is minus 1. Next, 1 gets multiplied with 2, we get 2. 1 gets multiplied with 1, we get 1. This is the first row. Second row, for second row, minus 4 gets multiplied with minus 1, we get 4. Minus 4 times 2, which is minus 8, minus 4 times 1, which is minus 4. Next, 3 times minus 1, which is minus 3, 3 times 2, which is 6, and 3 times 1, which is 3. This is what I have, right? So this is the product AB. Once you have the product AB, implies the product AB and its transpose, right? AB whole transpose can be found very easily by, let's get rid of this is not required. AB transpose is found by interchanging the rows and columns. The first row becomes the first column, as you can see. The second row, 4 minus 8 minus 4 becomes the second column. The third row becomes the third column. This is what I have. This is what I have at the end. What next? So on the RHS, you have something else. This is the first statement, right? This is the end product, end result for the LHS. For the RHS, first we need B transpose. Okay. So, okay. Given we are already given that B equals this, or we can say this is statement 1. Let's call this statement 2. So from statement 1, we get B transpose easily. What is B transpose? Is equal to B transpose is the transpose of this. This becomes minus 1 2 1, and A transpose is equal to the transpose of that matrix. This is 1 minus 4 3. This is what I get. This is the transpose of this column matrix becomes a row matrix, and the transpose of this row matrix becomes a column matrix, as you can clearly observe over here. Using B transpose and A transpose, therefore, the product B transpose, A transpose. Please observe, B transpose has to come front, A transpose has to go at the back, and B transpose is pre-multiplied actually. What you obtain from here is, this is minus 1 2 1 times 1 minus 4 3. This is what I get, and let's multiply them together. This is again a 3 by 1 matrix, 1 by 3 matrix. The final matrix that will obtain will be a 3 by 3 matrix. Yeah, that's what we want, right? Let's see, the products would also look similar. This is minus 1 times 1, which is minus 1. First row, second column, that becomes 4. First row, third column, that becomes minus 3. Okay. Second row, first column 2. Second row, second column, minus 8. Second row, third column, which is 6. Third row, third row, first column, which is 1. Third row, second column, minus 4. Third row, third column, which is 3. This is what I obtained. Right. This is B transpose times A transpose. That's what I obtained. Okay. This is statement 2. Sorry, this is statement 3. Let's see. And let's observe the matrices obtained at the end of statement 2 and statement 3. This is minus 1, 4, minus 3. Okay, that matches. The second row, 2, minus 8, 6 also matches. The third row, 1, minus 4, 3 also matches. And yes, we can say from 2 and 3, what do we observe? We observe that AB transpose is equal to B transpose A transpose. Hence, it has been verified. It has been verified. Okay, let me get aside so that you can take a look at this question. And let's move on to the next one after this. This is part 2 for the same question. What does the part 2 say? We have a matrix A, we have another matrix B, and we have to verify that the product A, the transpose of product AB is equal to B transpose A transpose. Let's do that. So matrices A and B are given to us. Okay, and using these matrices, we'll first find the product AB, then take its transpose. Okay. So let's do it. What do we have over here is given A equals 0, 1, 2, comma B equals 1, 5, 7. Let's call this statement 1. Given these are the two matrices, we are supposed to find the product AB. Okay, let's find the product AB then. This implies AB, the product AB can be written as 0, 1, 2 and multiplied with 1, 5, 7. Now this is a 3 by 1 matrix, this is 1 by 3 matrix. The product exists and the final order of the matrix would be 3 by 3. That's what you can observe. And what will that 3 by 3 matrix be? First row gets multiplied with first column to give us this. This is 0, the first row. Second column gives again 0. 0 times 7 is also 0. Second row with the first column, second column, third column will give us the second row. 1 times 1 is 1, 1 times 5 is 5, 1 times 7 is 7. Third row, 2 times 1 is 2, 2 times 5 is 10, 2 times 7 is 14. This is my matrix AB. And after you have obtained the matrix AB, can we find the transpose of AB? Therefore, AB transpose, take the transpose, and what you get by taking the transpose is 0, 0, 0 over here, 1, 5, 7 over here, 2, 10, 14 over here. This is the matrix. Let us call this statement. Let's call this statement 2. Okay. What else? Now using this statement, I can find B transpose and A transpose first of all, then take the product for getting the RHS. Yeah. So let's do it. Using 1, I can find A transpose is equal to what? A transpose would be 0, 1, 2. These elements would be present over here. And B transpose is equal to what? B transpose would be 1, 5, 7. Okay, B transpose would be 1, 5, 7. After that, we can get B transpose times A transpose. Therefore, B transpose A transpose, the product B transpose A transpose would be equal to what? Let's find that. B transpose is 1, 5, 7. A transpose is 0, 1, 2. And the product can be found very easily. This is 3 by 1, this is 1 by 3. The final product would be a 3 by 3 matrix. 1 times 0 is 0, 1 times 1 is 1, 1 times 2 is 2. 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10. 7 times 0 is 0, 7 times 1 is 7, 7 times 2 is 14. This is what I have. And this is the product B transpose A transpose. And let's call this statement 2. Let's call this statement 3. Okay. And observe the two matrices obtained at the end of 2 and 3. This is 0, 1, 2, 0, 5, 10, 0, 7, 14, 0, 1, 2, 0, 5, 10, 0, 7, 14. They are exactly same. Therefore, from 2 and 3, equation 2 and 3, we can say that this property AB whole transpose is equal to B transpose A transpose is true for these two matrices. We have verified that this property holds for these two matrices as given, right?